Hello, Internet. I'm really excited to be talking to you about Arri Schema. Now, Arri RPC is a project I've been working on for a couple years now, and part of building that ecosystem has been building this schema library. Now, Arri Schema is a TypeScript validation library that's similar to Zod. You can use it as an alternative to Zod, but it comes with a significant performance improvement over Zod. Here is an Arri schema, and here is the equivalent Zod schema. If we benchmark the performance of these two schemas, you'll see here, Zod is only able to do less than 500,000 operations a second. Arri Validating is able to do almost 82 million operations a second. That's 160 times faster than Zod. Arri running Parse is 20.2 million operations a second. That's 40 times faster than running Zod. Now, this is when the input matches the schema. When the input does not match the schema and it fails validation or parsing, the results are even more pronounced. Zod gets slower with about 300,000 operations a second. Arri running validate gets faster. Now it's going 91.5 million operations a second. That's like more than 250 times faster than using Zod. And Arri in parse mode is going 12.7 million operations a second, which is still about 40 times faster than Zod. So if you're sold already, I guess that's all you need to know. You can install this via PnPM, NPM. The documentation is pretty clear as far as how you go about using it and everything you need to know there. But those of you that may be curious how I achieved this kind of performance when we're validating in TypeScript, well, stick around and I'll explain what exactly I did to achieve this kind of performance and some of the trade-offs that came with those decisions. Now, the first thing to know about performance in Zod versus Arri is that in Zod, every kind of validation is an expensive parsing operation. So here I am parsing this object, and even though it matches the same shape as what the schema is defining, Zod will create an entirely new user object, right? It's going to essentially loop through all the keys of this, and it's going to construct a completely separate object. And the reason why is because it has to parse it and potentially run any transformations on the input. Arri approaches this problem a little bit differently. So yes, one, if we have a result here and we call a.parse, and we pass in some object. In this case, Arri will do any kind of transformations necessary, and it will allocate a whole new object. But Arri also has another method, which is .validate. And validate is for cases where you know you don't need to transform the input anymore. Instead, I just need to know, does this input conform to the shape of this schema? So validate actually acts as a type guard. So for example, if let's say we have some type that's an unknown. So now if I call a.validate our user foo, this acts as a type guard, which means that inside of here, I have access to these keys. So validate doesn't do any transformations. It doesn't allocate a new object. It just tells you, yes, this matches the schema. You can access these fields. This distinction is, one, a really important distinction to make, where not every time you want to see if a type matches a schema, do you want to do an expensive parsing operation. With Zod, every validation operation is an expensive parsing operation, when really you only want to do it once, right? It's like you really just want to parse the first time you receive JSON across the wire, and then after that, you don't actually want to parse anymore. You just want to do maybe a basic validation. So that's the first step. Arri distinguishes between parsing and validating. The second thing to know is, one, I want you to consider this schema that we just created. So here we have the same user schema. Now, under the hood, what Zod is constructing when you call this z.object and z.string functions, it looks something similar to this. So z.object actually initializes a new Zod object class. And then inside the shape field, you'll see that it's also initializing 3 Zod string classes. And every single one of these classes, they extend the Zod type, and they have access to the same kind of transformations, .parse, .parseSafe, .nullable, .optional, whatever it is, right? But Zod, for every time you call z.whatever, it is essentially initializing a whole new instance of this Zod type class. Let's compare this to how Arri works under the hood. Now, this looks pretty much the same, but when we expand it out, it actually looks something like this. You'll see here that we have a simple properties object, which has a key for every field in our schema. Underneath each field, you'll see that we have a simple validate function. Now notice here, we are referencing the same variable for each of these validate functions. And the reason why is because when we're validating a string, we simply are referencing a static function that allows us to validate a string. So when compared to Zod, notice how many less memory allocations Arri is creating versus Zod. Now let's explore what this looks like in practice. So here I prepared a couple benchmarks. So here we are, we are looping 1,000 times and we are creating 1,000 Zod schemas. And I just picked 1,000 because, that's about what you would get for a decent sized API. Maybe 500 endpoints, and then each one has like 2 schemas or something like that. And this is a really simple Zod schema, but all we're doing is we're just creating a new schema that's similar to the one that we showed before, and we're pushing it into this array. The other thing that we're doing here is, one, we are now going to print out the memory usage of the application. But there's a couple things I have to explain here. One, we have to print out the baseline memory usage first, because just running Node.js, there's going to be some memory already allocated and already in use before you even write in any code. After we fill up our list of schemas, then we're just forcibly calling the garbage collector and saying, okay, clean up everything so that I can measure what's left over. And then we're printing out the memory usage. So now let's see what this outputs. So you'll see here, the important thing that we need to look at is heap used. And the reason why is because JavaScript objects in Node.js, they get stored in the heap. And what we have to do is we have our baseline here. You'll see the baseline heap usage was 5.2 megabytes. And then the final heap usage was 14.65 megabytes. So we subtract this amount from this amount, and that's how we get our result. And that puts us at about like 9 megabytes. Now I've created the same exact benchmark for Arri. So you'll see here, we're creating the same exact schema, no differences. We're pushing it into a list. We're logging the baseline memory usage, and then we're logging the final memory usage. So now let's run this. And you'll see here, one, our heap usage is way lower. So 7 minus 5.5, that puts us at like less than 2 megabytes, versus here, we were at like 9 megabytes. So now I'm going to take these variables and I'm going to just plug them into this little chart. For 1,000 simple schemas, Arri is using significantly less memory than Zod is. And that's because those Zod schemas, they're big. And for every field, we have to create a whole new instance of this class. Now, this schema that I've shown here, it's kind of small. So let's actually run this again, but now let's use a larger schema. So you'll see here, I've got this big old schema here that's got a bunch of things. And this might actually be closer to what you might see and, maybe some enterprise grade whatever. And again, we're just going to create 1,000 instances of this guy. In the same way too, I created the same thing schema in Arri land as well. And you'll see it's just this big old schema. We're creating 1,000 of them. And then we're going to look at the memory usage. So now if we update our chart, you'll see here that Zod is approaching almost 150 megabytes of memory usage for just 1,000 of those schema instances. While Arri here is sitting at like 35 to 40 megabytes. Okay. This is a significant difference and it adds up, right? The more resources you allocate, the more things are going to cost. So now let's look at some benchmarks. So here we have on the right, this is Zod calling .parse. Here is Arri calling parse. And here is Arri calling validate. And notice how much faster validating is than parsing, because again, we don't have to do any transformations. We're just returning true or false. Yes, it matches. No, it doesn't match. Zod is doing less than 500 operations a second. This is on my machine. Results are going to vary. This is just to give you a general idea, blah, blah, blah. But you'll see here, Arri's parsing function, it's like twice as fast. And when we call validate, it's like 5 to 6 times faster with 2.7, 2.8 million operations a second. So this is when the input passes, like it fits the schema. When it doesn't fit the schema and it's a bad input, the results change a little bit. So you'll see validate got even faster. So now it's at 4 million operations a second, and Zod got slower with only 330 operations a second. So for good input, Arri validate is going 5 to 6 times faster. For bad input, it's going like 11 times faster. Now, I know what you're thinking. Well, Josh, the video title says 100 times faster. Okay, you're 5 to 11 times faster. That's not what you said in the video, right? And I promise it's not clickbait. And the reason why is because Arri has a second validating mode. Consider this Arri schema that I presented earlier. Now, one thing you may have observed when I expanded it out is that this has some additional metadata included in it, right? If all we need to do is loop over these keys and call validate, why are we also indicating that email is supposed to be a string, name is supposed to be a string, and ID is supposed to be a string? Why are we including this additional information in there? And the reason for this is because Arri comes with a JIT compiler. With the JIT compiler, we pass an a.compile, and that function, compile, it navigates over that tree of metadata that I showed earlier. And what it does is that if we expand this out, you'll see that it pre-compiles a high-performance validate, parsing, and serialization function. If we expand out, for example, the validate function, now it looks like this. We pass an unknown type, and notice how it is exactly grabbing the exact fields that it needs to check, because we're able to pre-compile this ahead of time. Now, the way that this works is actually pretty simple. You see, JavaScript, it's a interpreted language, right? And so technically you can do these things where you can evaluate code at runtime, right? And this will evaluate this and it'll run this. And I know what you're thinking, oh, eval, it comes with all these security concerns. But as long as you control what's being passed into it and out of it, you can actually use it to make high performance stuff. What Arri does is, again, it navigates over this tree structure and it constructs a new function. Something like this, validate user. This validate function only accepts one argument, and then it has a body like this. It says return, right? It's like type of input equals object, and input does not equal null, and right, it contains ID in input, and so forth, right? So this is being constructed when we call a.compile. This is being pre-constructed ahead of time, meaning that no longer do we need to navigate across this tree. No longer do we need to try and do these extra steps. We literally check exactly the fields that we need. But it doesn't just do it for validate, okay? It does it for validate. It does it for parse. We also have coerce in here. So if you want to coerce an input, like say you got a bunch of string keys and values, you want to coerce it into numbers or whatever it is, that does that. It also does it for serialize, which is faster, by the way, than calling JSON stringify. This is all done at compile time, okay? Now, the only caveat to this is that because under the hood it kind of uses eval, you can only run it in environments that you control. You can't run it in the browser. You can't use it in places like Cloudflare Workers. But you can use it on your server, where this is the most important. But this is the reason why Arri has these two modes. So for places where you can't use a precompiled version, you just call a.parse some input. For places that you can use the precompiled version, now you can use it. So now let's look at some benchmarks factoring in the precompiled version of our schema. So you'll see here, this makes a big difference. Here's our old validate function that was the fastest at 2 point something million. Here is odd, still at like 400 something thousand. And here is our precompiled validator, 79 million operations a second. Okay, so actually you're right, I did lie a little bit. In the YouTube video, it's not actually 100 times faster. This is actually 160 times faster. Additionally, even our quote-unquote slower parsing function, it's still 18.5 million operations a second. Okay, that's still like 40 times faster than Zod. It even gets crazier when we start looking at bad inputs, right? So these are things that fail validation. Again, Zod gets slower when an input fails validation. And you'll see here, now it's down to 340,000 operations a second, while our validate function is 90 million operations a second. So you're talking about now calling validate versus Zod parse is now 200 times faster. Additionally, our precompiled parsing function, while it does get slower, it's still about 40 times faster than Zod. So if you're using the precompiled validators with Arri, you're talking about a 38 to 40 times minimum performance increase over Zod. Okay, so now let's see how this stacks up against the rest of the ecosystem. This is a different benchmark that's from the Arri RPC repo, where I kind of keep track of how we're doing against some of the other ecosystem. Now the type is a larger user object that looks something like this. And I'm going to go through a couple of these benchmarks. Now, take all these numbers with a grain of salt. This is just to give us a general idea of performance. Don't get too caught up on exact numbers here, okay? This first benchmark is testing whether an unknown input passes the schema or not, right? It's just a true or false. Yes, it passes. No, it doesn't pass. And this is when it's a good input. So you'll see here, Arri is at the top of the pile here, and Zod is all the way down here at the bottom. Now there's a couple other interesting things in here. So here we have AJV, another JSON validator, and AJV actually holds up pretty well. And AJV also has a JIT compiled version that performs decently well. We also have Typebox here, and Typebox is similar to Arri in the sense that they have a runtime version of their validators. And then they also have a JIT compiled version of their validators too. And you'll see that Typebox actually performs pretty similarly to Arri here because they're using the same strategy. And honestly, I've kind of borrowed this strategy from Typebox. So this is validating an object with good input. Here is validating an object with bad input. So this fails validation. And as before, Zod got slower. Typebox got a little bit slower. Arri got faster when validating, but everything holds up pretty well. You'll see Arri right here, we're coming up on 56 million operations a second. Typebox here is at 45 million operations a second, and then down here Zod is at like 300K, and Zod is definitely the slowest out of all of these. The next benchmark here is one that's probably the most common occurrence, which is parsing JSON. Usually you're going to have one of these schema libraries sitting on a server. When it gets JSON coming in from the client, it's going to call JSON parse, it's going to run it through the validator, and so forth. Now, Typebox, Zod, Valibot, and most of these libraries, they do not actually parse JSON. By default, you actually have to call JSON parse and then like Zod parse. So I've accounted for that in all of these benchmarks here. Conversely, Arri, actually, you don't have to call JSON parse. When you pass a JSON string to Arri, Arri kind of already does that under the hood, or you can just pass it a regular object and it'll also figure it out. Here in the middle, we have a standard JSON parse. It is the fastest out of all of these, but obviously no validation is happening, right? It's just, I was able to parse the JSON and turn it into an object. Now notice here, the two libraries that use JIT Compilation to create these validators, both of them are actually coming up very close to JSON parse, just a raw JSON parse. So here we have Typebox, where you call JSON parse, and then you call Typebox to validate whether it passes or not. And Typebox is just a tiny bit slower than a vanilla JSON parse call. In the same way here, we have Arri, which has a compiled parser, and it's also just barely a little bit slower than a vanilla JSON parse. And I really put a lot of time into optimizing this specific use case because this is the most common. And so if you use something like Arri, it just adds a little bit of overhead on top of a regular JSON parse. Meanwhile, with Zod, you'll see here it's several times slower to call JSON parse and then pass it over to Zod and see if it actually matches the schema. That's going to be the case with most of these JavaScript libraries. So now let's go over what it looks like when we parse bad input. Now, the first thing I want to say here is, one, most libraries get slower when they get bad input. I will say, though, take this result for Typebox with a grain of salt. And the reason why is because Typebox, they don't have a safe version of their decoder that doesn't throw an error, which means I had to wrap it in a try-catch to do this benchmark. And in my experience, the benchmarks, they get kind of wonky once you start having try-catches involved. So take this result here with a grain of salt. Just going to leave it at that. But in this case, you'll see that still Arri is barely slower than JSON parse. And you'll see Zod, Valibot, even AJV, even their JIT compiled version, it's still several times slower. And so your server is going to be impacted by that performance. The next benchmark is object coercion. Okay, so this is things like coercing a string into a number or into a Boolean and stuff like that. The only libraries that I saw that had this kind of coerce method was Typebox and Zod. And you'll see here, the runtime version of Arri is like twice as fast as both of them. But then the compiled version is just miles and miles faster. You could use this, for example, if you're receiving some query string parameters, right? You map them out into an object, pass this over to Arri, and it'll coerce them into like numbers, Booleans, and it'll tell you if it is a valid number or Boolean. Way, way faster than the alternatives. The next one, and this is a fun one, and if you watched my previous video, then you would already know about this, but this is object serialization, okay? So over here on the right, you'll see we just have a vanilla JSON stringify. You can pass any object you want, and it'll turn it into a JSON string. But since Arri is JIT compiling out a serialize function, you'll see here that we're several times faster than the native JSON stringify implementation, even though it's a JavaScript function. It's because we're able to know exactly what fields will be available and turn them exactly into the correct string. In fact, Arri is fast enough that we can validate an input and we can serialize it more than twice as fast as a vanilla JSON stringify. So these are all really fun things. The only other library that I knew of that had this serialized method was AJV, and it's only AJV running in JSON type definition mode. So not the JSON schema mode, JSON type definition mode. Now let's talk about some of the caveats and asterisks. Those of you that may have been paying attention earlier, many of you may have been, oh, well, actually, those schemas were not actually equivalent, right? That email field in Zod, it has an extra validation. Arri isn't using a .email type, and this is true. Zod has a number of additional runtime transformations and checks that are not available in Arri. And there's a couple reasons for this. The first one, Zod can essentially run a transformation at any time, right? I can call .string.transform, but the problem is this field right here, there is no way for me to statically compile this .transform because this is something that users of the library would be adding at runtime, right? So there's no way to know what's happening inside of this transform thing. So Arri, you can't have dynamic transformations. That's a downside because there's no way to statically compile it. 2, any kind of these special string cases, they are things that need to be handled now in 2 places. They need to be handled here when we call arri.parse. And they also need to be handled here, which means that I would have to have static compiled validation versions for every single one of these things, right? They have nano ID, they've got UUID. So what I mean to say is, as a caveat, Arri will never have quite the same flexibility that you get with Zod. And it's because Zod lets you pass in these dynamic transformations, and they have all these helpers for all different kinds of different string types, right? You can even call string.emoji, and it'll validate whether it's actually an emoji character or not. If we were to add any of these to Arri, we would now have to have static versions of all of those that can be compiled out. We have to have like a compilable version of emoji, a compilable version of email. And I'm not against adding maybe a couple of these, but Arri will never be able to have the same kind of flexibility that Zod has, because any functionality that's available in the runtime validators has to be available also in the pre-compiled validators. The other thing too is these are all the primitive types that are available with Arri. And I want you to notice something. So we have string, timestamp, boolean, float 32, float 64, int 8, int 16, int 32. And you might be wondering, wait, why are there so many number types, right? You don't even have these available in JavaScript. And the reason for this is that Arri actually was created for a different purpose. So yes, it's a TypeScript and JSON validator. Yes, it can be used to improve your server performance, but it was actually created so that it can be compiled to other languages. So you'll see here we have that same user type. And let's say we want to make this field nullable. We'll just make it nullable. We hit save, and look at what has happened here. In Dart, the string is now nullable. In Rust, it's an option type. And Arri supports Swift, Kotlin, Rust, Dart, TypeScript, all that fun stuff. So the reason why we need all of those different number types is because they exist in different languages, right? If I put num followers and I make it in int64, you'll see that in JavaScript land that this becomes a big integer. While in Dart, it's a big int, and in Rust, it's an I64. Okay. So the other reason why Arri can't have these kinds of runtime transformations and all these many different string validations is because, well, for every single one of those, it needs to be consistent across every single language that Arri compiles to. And so while it's doable, we kind of have to pick and choose our battles. So if this project is interesting to you, I encourage you to go over to the Arri repo, give it a star. It is under active development, and I'm in the middle of finishing the Go server, which is going to be really exciting. And look forward to some of my future videos because there's some exciting stuff that's coming down the pipe.